In exercise 404, we look at this concept called relative frequency. I touched on this very briefly when I introduced the concept of the formula for calculating probability. And remember, I said that this formula is the theoretical calculation for what the probability should be in theory, but we know that it doesn't always work that way. And what happens in reality is this concept called relative frequency. So relative frequency is the measurement that we get after conducting an experiment. So you can see here that we're going to look at, in this example, the relative frequency of car accidents in this particular town over a month. Now, as you can probably appreciate, that's valuable information for people giving quotes for insurance, etc. So this is a calculation with a real life application. So just a few things to note before we get onto that is it could be called experimental probability, and its name is very suitable because it's the probability based on an experiment. The other name that you may not be so familiar with is this relative frequency. So this is something that needs to go in your summary, and please note the relative frequency of an event is the observed frequency of the event, observed from collecting data or running an experiment, over the total frequency. So we're going to be using that, and even in the next exercise, we're going to be comparing the results we get from an experiment with the theoretical results that you get from just in theory what should happen. And if you remember back when I was talking about theoretical probability and saying that if you roll the dice, you'd expect to get a 6 theoretically once in 6 rolls of the dice. We know that doesn't happen. I'm sure many of you have rolled the dice 6 times and never ever got a 6. You might have rolled it 10 times and still not got a 6. So when we've got that situation, we would talk about the relative frequency of getting a 6. So like I said, we're going to compare these two measurements in exercise 404. But for now, let's have a look at this table where the number of accidents, the frequency of the accidents, has been recorded next to times throughout the day. So the first time is from midnight to 4 a.m. Now, as most of us know, there are fewer cars on the road. There should be fewer accidents. So there were only 4 accidents recorded. Starting 4 a.m. to 8 a.m. in the morning, people are starting to travel to work. And yes, the number of accidents increased significantly, up to 13 now. From 8 a.m. to noon, all sorts of things still going on. People going to work, students going to school, etc. We're now up to 17. From noon to 4 p.m, we also have a high incidence of accidents, people coming home, lots more cars on the road, and also as we get into the afternoon, maybe people are more tired. And 4 p.m. to 8 p.m, we're certainly hitting afternoon traffic, end of work traffic, 5 p.m. And again, people getting very, very tired towards the end of the day, more likely to have accidents because of those two things, people becoming more tired and increased numbers of cars on the road. But then from 8 p.m. to midnight, the number of accidents reduce again because lots of people are home, less people on the road. So says, based on these results, what is the relative frequency of a car accident in Uptown occurring at A between midnight, so probability midnight to 4 a.m. We need the number of accidents occurring in that time, which was 4 over 84 accidents in total, and I get that from summing the total number of accidents. Now, we could reduce that to 1 in 21. So please be aware that you need to reduce the fraction or simplify it, and you can do that very easily on your calculator by putting your fraction in and pressing the equal sign on the calculator. It will tell you 1 in 21. Part B wants you to find the relative frequency. Just note I've corrected that notation. It's not the probability, it's the relative frequency. So the relative frequency, an accident occurring between 8 a.m. and 4 p.m. is, now be careful, 8 a.m. to 4 p.m. we need to add this 20 and 17, and that's where the 37 comes from. Out of 84, I don't think that can be simplified. Also be careful with C, so we want the relative frequency that after midday. So that assumes until midnight, because that's then starting the next day after midnight. So after midday means we have from, let me bracket this in green now, we want starting at noon and going right through to midnight. So we've got 30 and 20 there, which is 50 out of 84. Now, when we simplify that, it will go down to 25 on 42. And then part D wants the relative frequency that an accident occurs earlier than 8 p.m. at night. So you can see I've bracketed all the accidents up until 8 p.m. at night, and that is just 7 less than 84. So you can add them up, but a quicker way to do it is to think about 7 less than 84, which is 77 on 84, and 7 goes into both those, and it's 11 in 12. So you can certainly see that 11 out of 12 is indicating almost all the accidents occur before 8 p.m. at night. And that should be enough for you to be able to get started on the next exercise. Don't forget to fill out your summary and key points for this topic. And it's probably really just like I've highlighted back here. You need to know that formula.